Please pause the video and read the problem. Alright, first one. Draw a tree diagram for selecting a person from this population. This example talks about a prostate cancer test of men 50 plus. First, understand how many branches we need for the first stage. There are 2 branches. What are the outcomes? We need to write down the outcomes at the end of branches. Cancer present and cancer absent. I say cancer and no cancer. Now we need to find the probabilities. What is the probability of cancer? It was found that about 6.3% of the population has prostate cancer. Therefore, probability of cancer is 0.063. Now we can find the probability of no cancer. How do we find the probability of no cancer? Since the total probability of these 2 branches must be 1, 1 minus 0.063 is the probability of no cancer, which is 0.937. Now understand the second stage. How many branches we need? From the table, we have test result positive and negative. Therefore, we need 2 branches. We can say test positive, test negative. Now we need to find the conditional probabilities. First one, probability of test positive given cancer present. That is 0.21. What is the next conditional probability of test negative given cancer? It is 0.79. The total probability of these 2 branches must be 1. So go to the next. Probability of test positive given no cancer. The last one, probability of test negative given no cancer. Those are conditional probabilities. Now we need to find the probability of cancer and test positive. How do we find this? Multiply these 2 probabilities. So that is the probability of cancer and test positive. Then find the probability of cancer and test negative. Multiply these 2 probabilities. It is 0.04977. You can find the rest of the probability the same way. Now let me consider this tree diagram and define some events. I define B1 as a cancer is present. Therefore, we can write probability of B1 is 0.063. B2, cancer is absent. So we can write probability of B2 is 0.937 and define another event as A. It is test is positive. Now we can write the conditional probability. What is this? That is the probability of A given B1. Next go to the 0.06. That is the probability of A given B2. What is the probability that the test is positive for a randomly chosen person from this population? That is the probability of A. How do we find the probability of A? Consider the tree diagram. There are 2 groups. Probability of B1 and A and probability of B2 and A. To find the probability of A, we need to add these 2 probabilities. Probability of A is 0.06945. What is the false positive rate when the PSA test is used to screen for prostate cancer on this population? That means no cancer but test is positive. So probability of B2 given A. Then how do we find this? We know conditional probability formula. For this case, we can write probability of A intersection B2 divided by probability of A. What is the probability of the numerator? It is from the tree diagram. What is the probability of A? That is from the previous question. So we know the probabilities, then divide, that is 0.81.